Hello there, this is Miss Martinez. We are looking at Chapter 9, Section 2. It's titled Multiplying and Dividing Rational Expressions. So as a student, what I'm looking for you to be able to do is to multiply and divide rational expressions and to simplify complex rational expressions. I'm going to show you how to do that in this instructional video. So let's get started. We're going to work with multiplying rational expressions first. As you can see, I have one rational expression times another, and we're asked to simplify that product. The first thing you want to do, because everything in the numerator is already being multiplied, and everything in the denominator is being multiplied, you want to cancel common factors. And like you did with fractions, you can cancel on the diagonal. So the 2 and the 8, those simplify. 2 can divide into both, and so what would be left is just a 4 in the numerator. The a's, you can cancel those, and only one a would be left in your denominator. For the 5 and the 25, you can divide out a 5, and a 5 will be left on top. And for your c's, there's 1 on the bottom and 1 on the top. Well, I'm sorry, 2 on the bottom and 4 on the top. You can cancel out 2 from each, and that'll leave you with c squared in the numerator. Now that you've simplified, it will be much easier to multiply. You're only multiplying the remaining factors in your numerator and denominator. You'll have 4b, that's what was left for your first term, for your first rational expression, 4b over 1, and 5b squared times c squared over a. That means you'll have 20 b cubed, because you add, when you have like bases, you add your exponents, and c squared over a. If you have any questions on this example, maybe you're not really familiar with your properties of exponents, write that question in the margin and we'll definitely discuss that together. Alright, an important note. When you're working with this simplification, you will need to factor any polynomials in the numerator and denominator in order to cancel common factors before simplifying. Let me show you in this next example what we mean. Here we are multiplying polynomials. You have a quadratic polynomial divided by a quadratic polynomial times a binomial over a monomial. And we want to first factor both your numerator and denominator for each of those expressions. For your first expression there, you can factor out a 5. It is a GCF. And in that first expression's denominator, you can factor out a 3. It is also the GCF. In your second expression, you can factor out a 3 as the GCF, and in the denominator, nothing can be done. Now right away I can see that I have a 3 on diagonals there in the numerator and denominator, so I'm going to cancel those out just to kind of make life a little bit easier. But we're still going to have to do some more factoring because we have quadratic polynomials still in our numerators and denominators. So let's continue to factor and then cancel if possible. Alright, so that numerator, the quadratic polynomial, would factor if you used the cross to x minus 5 and x plus 4, and the denominator would be x plus 4 times x minus 2. Alright, now everything is completely factored and expressed in binomials or monomials, and we will cancel out common factors. from the numerator and denominator. And that is all that we can cancel. So the final answer, we'll leave it in a factored form, will be 5 times x minus 5 over x. All right, now dividing. Just like with fractions, when dividing by a rational expression, you'll multiply the dividend by the reciprocal. Instead of division, you will multiply by the reciprocal. Let's do an example of this together. And we're also going to state the excluded values for this problem. So we are dividing by a rational expression. First thing, we want to try and simplify as much as possible, so we will factor the numerator and denominators for each and determine excluded values. That numerator for the first would be x plus 3 and x minus 2, and for the second expression in the denominator you can factor, and it would be x minus 6 times x minus 1. Our excluded values would be 6 or 1. All right, now, instead of dividing, we are going to rewrite this as multiplying by the reciprocal. So you'll see that the second expression has been flipped. The numerator and denominator have been flipped. That is called the reciprocal. Now we will try to simplify and multiply like we've been doing. Like factors in the numerator and denominator can be canceled. And the result would be x minus 2 times x minus 1 in the numerator. We've eliminated everything from the denominator. This could be rewritten if you multiplied. If you use the property of distribution, it would be x squared minus 3x plus 2, and your excluded values again are 6 and 1. You wouldn't necessarily have to multiply your binomials. I just wanted to show you that result. All right, last example here. Simplifying complex rational expressions. What you're seeing here is a complex rational expression, and if I recall correctly, these are very likely to show up on many standardized exams that you all have to take. So how do we simplify this? This looks crazy. There are so many layers. Well, I like to, and in your notes I've kind of put parentheses around what is truly your numerator and what is truly your denominator. And then you can write this just as division, because you're dividing a rational expression by another rational expression. When you do that, you can factor, so x squared minus x minus 6 is really x minus 3 and x plus 2. And the denominator of the denominator would be x minus 3 and x plus 3. That's a difference of squares. That's a special type of quadratic. Now, like we were doing, we need to state our excluded values. That would be positive 3, negative 2, and also a negative 3. Then we'll write the product of the reciprocal, because we don't divide rational expressions, we multiply by the reciprocal. So the second term, the numerator and denominator have been flipped, and the operation is now multiplication. We will simplify and then multiply. You can cancel those factors there, as well as these here in blue. I've made those slashes. And so we're going to have a much simpler result. It's just 1 over x plus 2, where x cannot equal 3, -2, or -3. And that is it. You all now have seen how to carry out every objective from this lesson. And if you had any questions at all, no matter how small or big, write them down in your margins and we will discuss them in class. Thank you and have a wonderful rest of your day.